In this video, we are going to be looking at using forces as vectors. The first question says a particle is acted on by three forces. We've got 2i plus 5j newtons, 3i minus 1j newtons, and pi plus qj newtons. So our I forces act in the x direction. So a positive I is going to go to the right, a negative I to the left, and J's act in the y direction. Positive J is up, negative J is down. So this first force, 2i plus 5j, acts 2 to the right and 5 up. So overall, 2i plus 5j will go in that direction. Given that the particle is in equilibrium, if it's in equilibrium, that means the forces are balanced. Forces left equal forces right, and forces up equal forces down. We need to find the values of P and Q. So the I's have to add up to 0, and the J's have to add up to 0. So 2i plus 3i plus pi must add up to 0. So P has to be -5. And the same for the J's. We've got 5 minus 1 plus Q has to add up to 0. So 5 minus 1 is 4. Q has to be -4. One for you to try. See if you can give it a go. So again, we've got a particle acted on by three forces, and it's in equilibrium. So that means the I's add up to 0 and the J's add up to 0. Forces left equal forces right, and forces up equal forces down. So for the I's, I've got 5 plus 2 plus P. That has to add up to 0. So P must be -7. And for the J's, I've got 3 minus 7 plus Q equals 0. 3 minus 7 is -4. So Q must be a +4. A particle begins at rest at the origin. It's acted on by three forces: 2i plus 5j newtons, 3i minus j newtons, and 1i plus 4j newtons. Find the resultant force. So what is the overall force? This time we're not in equilibrium. We've got a resultant force, an overall force. What is it? So I've got 2, 5. I've got 3 minus 1. And I've got 1, 4. So I'm just going to add up the I's. 2 plus 3 plus 1. That's 6. And the J's, 5 minus 1 plus 4 is 8. So the resultant force is 6 I's plus 8j newtons. Work out the magnitude and the bearing of the resultant force. So it's going 6 to the right and 8 up. So the magnitude is the length of the hypotenuse. So it's the square root of 6 squared plus 8 squared, and it's a Pythagoras triple. It's 10. So the resultant force is 10 newtons. And what is the bearing? So we want to know, so a bearing is from north. So here's a north line. We want to know the size of this angle here. There's a few different ways of doing it. So we could just work out this angle, which will be the angle we want because they're alternate angles. Or you could work out the size of this angle and do 90 minus the answer. I'll do that. So we've got the opposite and the adjacent. So tan x is TOA, 8 over 6. Shift tan, 8 over 6. Gives us 53.1 degrees. So 90 take away the answer is 36.9 degrees. So I'll call that 037 degrees. Because it's a bearing, I'm giving it as 3 figures. So 037. One question for you to try. See if you can give it a go. So again, we're going to find out the resultant force. So just add up the forces that are acting on the particle. 6(1) plus 4 negative 3 plus 2, 7. 6 plus 4 plus 2 is 12. 1 plus 7 take away 3 is 5. So we've got 12(5). So it's 12I plus 5J newtons. And the magnitude and the bearing of the resultant force, again, we've got a Pythagoras triple. So it's 12 to the right and 5 up. So the square root of 5 squared plus 12 squared is 13. So it's 13 newtons is the resultant force. What's the bearing of it? So bearing is measured from north clockwise. So that's the angle we want. Let's do 90 minus answer again. So the opposite and the adjacent. Tan x is 5/12. Shift tan 5/12 is 22.6. So 90 take away 22.6 is 67 degrees. It's a bearing, so we'll give it as 067 degrees.